Hi everyone, welcome to Bash scripting tutorial for beginners, where we are going to learn what is Bash, why is it so cool, and what can you do with it. So the idea is that Bash, or scripting in general, is like having a magic wand. You can imagine whatever you want to have on your Linux computer or remote VM and make it so with Bash script. A little bit about Bash script itself. Bash stands for Born Against Shell. It's both a command line interface and a scripting language. And in a nutshell, Bash scripting is a program that writes commands inside a file. So you create a file, write a bunch of code, and execute the program. Here's an example of a very simple Bash script saying hello world. Why Bash scripting? First of all, you can automate almost everything. Again, if your daily driver is a Linux desktop, or if you have to connect to a VM that happens to run Linux, that's the perfect example where you can use Bash script to automate literally any aspect of your system. You can customize how your system looks like, behaves. It really helps in understanding the inner workings of Linux, because when you write scripts, you have to come up with various ideas and you have to read a lot, which is great. And finally, it's awesome for problem solving. If you have a task that you would like to accomplish, pull something from internet, transform into a CSV file and do something with it, Bash scripting is really great for it. Automation, well, this is obviously a main benefit of Bash scripting, and it's really the main goal of automation is to save time and reduce errors. So if you find yourself doing over and over again the same number of actions from your command line or generally in your system, that's a great sign that you might want to look into automating it with a Bash script. Customization, for example, you can use this sample function to pull weather for your location or any location that you want. And you can customize this, your prompt or terminal. It's just an example, but the possibilities here are endless. System understanding. When you write Bash scripts, you typically use a lot of built-in functions that are already present in your system. In this case, we are listing all the processes, and using a built-in grep command, we are checking for any processes that run as our user, which is captured in a user variable. So by writing Bash scripts, you will inevitably learn about various tools and commands that are present in your system. Problem solving, you can, for example, use this one-liner to find all the files with an extension log, and then use another command line called xargs to check for presence of errors. And you can incorporate this within a Bash script. So what we're going to be doing today is we are going to build a very simple Bash script, and we are going to learn the key concept as we go. So at the end of this video, you will have a solid foundation of Bash scripting, understanding of basic principles, and you will be able to start coding right away. So the goal is to understand the building blocks, not necessarily to create a specific tool. The script we will be working on is just an example, but the primary goal is to understand the main parts of Bash scripting. So let's begin. The first thing we are going to do, before we start, maybe I'll introduce you to what's happening here on the screen. You can see I am using Tmax, and I have split my screen into 4 separate panes for better readability. On the right-hand side, we have, well, a Bash script that actually shows some man pages from a Bash documentation. You can just read it if you're bored of looking at the script, or just something to be a little bit more entertaining. At the bottom, we have a simple ASCII graphic reminding you what video you're watching. All right, so let's start by writing a simple script. I'm actually going to edit my demo file real quick to delete this since we don't need this anymore, and let's start a demo. So the first line in our script always starts with shebang. Where does the word shebang come from? You can see that we have hash, an exclamation mark, or otherwise referred to as bang. So if you pronounce it, it's shebang. What this line does, it actually tells the interpreter where to search for a program that is going to be used to interpret and execute our script. In our case, the program is called bash, and instead of pointing to it directly, we are using an env, which is another tool that knows where all the programs are. So if we change the default location of bash, using this env approach is safer because we're not going to get any errors or exceptions. So the next part is settings. Bash enables various settings by using a set keyword. Those settings that you see on the screen are very sane defaults, and I would encourage everyone to have this specific line in every script. What I do, I have a very simple snippet in my NeoVim setup, and I'm just pasting this snippet every time I write a new script. So let's break this down. Set is a keyword that sets parameters within our bash script. -e stands for immediately exit if encounter a non-zero status. Exit codes are something that bash uses to know whether the program executed successfully. If an exit code has a 0 status, means everything went well, and if an exit code has a non-zero status, then something went wrong. The exit codes actually have meaning, very similar to HTTP status codes, if you're familiar with them. But it suffices to say that if there's a non-zero exit code, that signifies that something went wrong. And this is how other tools in Unix and Linux systems behave as well. They will output a non-zero or zero status code. We can check the status code by outputting a $? Variable. Right, the next one is -u. That means treat unset variables as errors. When we write a script, we use variables to capture values, whether we assign them directly within the script or those are results of a command. If it happens that the variable at the time of assignment is not available, then the script will raise an error. This is something very similar to handling nil values or null values in programming language. And finally, type fail. To put it simply, it means that if you pipe the output of your script into another command, or if you pipe the output of a command into your script and this produces an error, your script will stop and exit with an error. All right, so we have settings. Now let's talk briefly about functions. Functions, as you might be familiar from other programming languages, are really the basic building blocks of any programming language, really. So in this case, the function anatomy is simply a function name. Then we have opening and closing braces, curly brace, and within the curly braces we have arbitrary amount of code. What is special about the function that you see is that it references a $1. What is a $1? $1 is a function parameter, but this parameter, as you notice, is not passed to a function within the braces like you might be familiar from other languages, but this is actually an ordinal parameter. There are ways to pass more structured parameters to functions, but this is outside of the basic tutorial. So for now, suffice to say that every function might receive 0 or more parameters that are ordinal, meaning that $1 is the first parameter, $2 would be second parameter, and so on. $0 is always a name of a script that we execute, and it's omitted. So in this case, what our function will do, it will use the echo, which is a built-in Linux function that outputs text to screen, and it will wrap whatever parameter we pass to our function between equal signs. Right, so let's talk about variables. Variables, like in any other programming languages, allow you to reuse data and to capture values. So what is specific in Bash is that the syntax is very strict. So you notice that we do not have any spaces between the variable name, which is name in our case, and its value. And this is by design. If you put space, Bash will interpret it as a symbol, and this will not work. So name is the name of our variable, and the value you see we have $, and some other signs. So we quote variables to prevent word splitting. If you don't quote a variable and your value has spaces, then Bash by default will split those words with spaces. We will not have the result as we intended to be. So now we also have $1, which you've also seen here on the top. Those are different. This $1 is a parameter of a function, whereas this $1 is an argument provided to the script itself. We will see later how to run a script, but you can imagine that you put a script name, and after the script name, you provide an argument, an arbitrary number of arguments. They are, again, ordinal arguments. So in this case, we say whatever first argument is provided after the script name will be taken, and its value will be assigned to the variable name. Now, this syntax, curly braces, colon, minus, is one of the operators in Bash, and it has many of those. You can read all about them in the manual. But what it essentially is, it means that either use a value provided from the parameter, first parameter, or if this parameter is not provided, use an empty string. You can also provide a default value here as a fallback. So you might be familiar from other programming languages. This is like a way to provide a default value. All right, let's talk about error handling. It's very typical if we want to make sure that user provided a correct values, we want to validate the input. So here we have a few things happening. First of all, we have an if keyword, and you notice the way how the if construct is done in Bash. We have if, what we evaluate within if. We have semicolon, the word then we have the content of what should happen if the if statement evaluates to true, and then we end the if block with simply a reversed if word, which is fi. And this works for other constructs as well. You start with if, and you can just mirror it to close it. Now, these double square braces are actually an expression. It's a conditional expression that evaluates whatever is between the braces and checks whether it's true or false. So in this case, we are using $pound, $hash, which is a special variable that holds a number of arguments, and we are comparing it to the number 0. So this minus EQ stands for equals. You also have minus GT for greater than and similar operators. So in this case, if number of arguments equals 0, that means it's an error because we are expecting the number 1 to be a name, which we're capturing in a name variable. If this evaluates to 0, then we are producing an error message. we are instructing the user how to correctly use the script, and we are exiting with a code 1. Remember when we talked about -e? If this happens, if we produce non-zero exit code, the script immediately finishes it and exits back to the command line. All right, let's use our function. So what we're doing here, we have a print header. Now you see to call our function, we simply type the function name without braces, and after a space, we put a value in quotes. So what can happen, you can imagine, if we use this function print header, it takes the value welcome, which is the first parameter, remember the ordinal parameters, and this welcome is being substituted right here. So we will end up with echo 4 equal signs, space, welcome, space, and 4 equal signs. Notice that the function doesn't return anything. There's no concept of returning values in Bash. You simply output text to a terminal using echo or perform any operation. So the signature of the function doesn't have a return value at all, simply because we are always operating on text. So if you return anything, this is going to be text, and you can capture it by using echo. Now, when we execute our script, the script executes from top to bottom, and when it encounters the function definition, it just registers it. It doesn't execute it. It executes this, it executes our if statement, and it now executes the function. So it jumps back to the definition, executes it, and then goes a line down. And the next line we have an echo statement where we say hello, and remember we captured our variable, that's name. When somebody launched our script, they provided their name, so it will evaluate to whatever name is being provided. Again, we use quotes, where we enclose our variable in quotes, and it simply prints out the welcome message. All right, now let's talk about loops and iteration. Bash follows a C-style loops syntax, and it provides multiple ways of iterating over data. In this example, we are using while loop, and this while loop always evaluates to true. Because of this loop will be infinite. So when you do construct like that, while true, semicolon do, then done, between those keywords, you can put whatever you want, and this will forever loop. Of course, we not always want it to loop forever. Then there's a break keyword to stop the loop and proceed to the next line in the script. But what are we doing in this loop? We are using the read tag p keyword to actually capture user's input. You might know from other programming languages to use the keyword input, or there are various ways of doing it. In Bash, we simply are reading the line that user provides. So we first are displaying this paragraph. How many files do you want to create? And we just put in braces 0 to 5. And you can see here, this is a variable. We are capturing whatever user puts as a response in the variable called num files. Now we are doing something interesting. We are again validating input, and we say if the num files variable evaluates to regular expression, and this is very powerful in Bash scripting. You can use regular expression to evaluate whatever variables you want or whatever values you want. In this case, it's a very simple regular expression. It says it must start from a number between 0 and 5 and ends. So this square braces in regular expression is group. So we have a group of a number between 0 and 5. So if this is true, if user inputs either 0 or 1 or 2 or 3 or 4 or 5, then we are going to break and continue. However, if user inputs anything else, whether a word or a number that is smaller or bigger, then we are going to output to the screen, please enter a number between 1 and 5. And because we are in an infinite loop, we are looping again. So we are essentially going to keep the user in this loop until they provide a valid number. So we've covered a lot of ground with this. Let me quickly recap. So while true is one of the ways we can iterate over data in Bash. And in this case, we are using it to validate user's input. Read captures user input into a variable. And we have, again, conditional with evaluation expression that uses regex to help us ensure that whatever user gave us as an input is actually a number between 0 and 5. All right, so we've talked about if as one way of doing conditional logic, but there's some more that we can do with conditional logic. One other conditional logic that we can use in Bash is case. And by the way, you see what we've talked about before. We have case enclosed in ESAC, which is mirrored or reverse of case. So in this case, this is like select case statement from other programming languages you might be familiar with. But in Bash, the syntax is as follows. So we are evaluating whatever value is captured in the num files, which we declared here. By the way, you notice that I didn't have to declare the variable first. I declared it in flight, in line here, and the variable is available to the rest of the script. So we say whether the value of num files is in various ranges. So either if it's 0, then we kind of output no files will be created. If it's between 1 and 3, again, we're using square braces here to denote a range. We're just outputting different text to the screen. And finally, 4 and a 5. So this is a way of how you can branch your logic and do something more interesting. Now, we have seen how we can use while to loop over arbitrary data, but we can also loop over arrays. So far, we have captured the user name and we have captured the input asking user how many files they want to create. So we can capture it into an array, very similarly like with other programming languages. We could use the word declare here or just a shortcut files equals empty braces, and this denotes an array. An array in Bash is simply a new line delimited array, unless we use a different way of delimiting it, but it's a little bit too much for starters. So think about it as just simply a bunch of words or sentences delimited by a new line. And now we have another way of looping over. So we are actually looping into for loop. We could also use for each loop, but in this case, we just want to loop with an iterator number. And this you might be familiar with from other programming languages. We are essentially iterating a set amount of times. So here we are using I equals 1. This is our starting, our seed, and then this is our evaluation condition. So we are evaluating whether our I is smaller or equals the number of files. And then the action, we are incrementing I always by 1. So each loop iteration will increment our counter by 1. Then we create a variable file name, and you can see we use again variable substitution. $I refers to this variable. So when we iterate first time, it would be 1. When we iterate second time, it would be 2, and so on and so forth. And then we use the echo command. We output text. This is file number, and it's going to be 1, 2, 3, 4, 5, depending how many files user wants to be created. And we use a redirect operator. This greater than sign, in this case, creates a file. So to be more specific, it takes the text on the left-hand side of the operator and it puts it into a file. And since a file name every time will be different, then we are going to create the number of files. So once this happened, we are capturing, so adding a file name to our array for later reuse. So let's go through this real quickly one more time. We create a loop, we start a loop. Inside the loop, we have a variable that captures our file name, that creates our file name, that is constructed from static words file, underscores, and a txt extension, and a dynamic index of our looping. Then we simply put this text and create a file name, which again evaluates to whatever value comes out of it, file underscore 1 and so on. And then we add this file name into our array. So really efficient way of creating files with some text inside. Of course, the example is trivial, but you can imagine how you can expand it into doing different. So now we are reusing our function one more time. Remember, with the function print header that we used with the word welcome now, but we are actually providing created files. So you remember, this function had equal signs, and it took whatever we provided as parameter and appended equal signs at the end and provided this value. Now we are iterating over the array. So here in this loop, we have iterated X number of times, which evaluates to however many files user wants to create, either 0 or 5. And in this, we are iterating over our array. So this array can have 0 files. If array has 0 files, simply those loops will be triggered 0 times. You don't need to put any checks, they will just be skipped. But if there's 1 or more files, this array will hold all those files, all those file names, and we say for file in. So this is like an for each style of iterating. It's not exactly for each, the Bash also supports for each, but it's for element in array or collection. Now, Bash has unfortunately a really quirky syntax when it comes to handling arrays. You just need to remember that, or ask ChatGPT to remind you. You essentially use the word files, which is the name of our array, and then in square braces you put @ symbol, which denotes that this is actually an array and we don't want to expand it, we rather want to treat it as an array. Now this weird monstrosity is something that think of it as a helper function in Bash. So this ## star /, those operators or built-in functions, they help us to essentially work with path and file names, directory, base path, and so on. Because it's very common in Bash to refer to a path or a file name. This is actually how we can do this. So what it does, it removes a path and shows only a file name. Because you remember on the top we have added to this file name, but when we add a file name here, it will come with an appended path to it. So whatever directory we execute the script in. So in this way we can remove it, and again we essentially iterate over it, and we take the value of a single file and we just manipulate with those double hashes and star to show only the file name. And this will essentially tell us how many files we have created and show us the file's name. It might be confusing. I still look it up myself. There is a manual available and all other things that you can use to check it. Don't worry if you don't remember it. Those are really quirky things that Bash unfortunately is famous for. The syntax is a little bit archaic, but it's not that bad. All right, so this is just for demonstration purposes. If we would have a non-existent file that we would like to show, then the command would actually fail. But since we are passing it to something which is called DevNull, it's a special file that we can use in Linux when we want to take a file descriptor for errors. So you can think about it, 2 greater than, means I am taking the standard error output and pushing it over to DevNull. So it's like forgetting about it. So it will not really work. It's just for demonstrating how the exit function works. I probably should remove it from the script, not to confuse you. Right, so now we are printing the header for the third time, with this time saying script completed. So we used our function 3 times, and we explicitly exit with 0. We don't have to do this, because if there are no errors in the script will always exit with 0, but it's a good practice to explicitly exit correctly and exit incorrectly, or with the error codes if we cannot do it. All right, so this is the script. Again, the script is just to illustrate the main points and syntax of Bash. Let's go now and try to execute the script and see what's happening. So we are going to exit the script. Now, to run the script in the current directory, first we need to make sure that the script has executable permissions. This is part of Linux permission system. You can read about it a little bit more, but what it boils down to, we need to execute a command chmod or chmod with +x, which means we are adding executable permissions to the current script. And after this, we are able to execute the script. Remember, we discussed about ordinal arguments to a script. So our script is an example directory and it's called example.sh. This is the script that we've just built together. And we are passing here Alice as a name. So remember at the beginning, we wanted to capture a name. So that's how we are passing this parameter. Just after space, we are passing here a name. If our name would contain spaces, we would have to quote it. So we have passed Alice here, and now let's execute it. So our script works as expected. We have welcome enclosed in equal signs, and it says, hello Alice, welcome to Bash script. How many files do you want us to create? Let's create 4 files. I created 4 files. The script went and create all the files. Again, used our function as a header and outputted the names of the files as we expect them to. Now, let's see if our validation logic works. So we're actually going to call the script without providing any name. So we essentially have 0 parameters. You might remember this logic branch that checks the parameter. Let's see if it works. So this is how we call the script. And yeah, it worked. So it produced an error, name is required, and it actually says usage. We use the parameter $0, which you might remember is the name of the script, and then it instructs us to add a name after the script. Okay, let's try also providing incorrect number of files. So we are going to respond with the number 10, which is outside of the range of accepted values, and let's see if our loop will loop again. So let's do this right now. So I have a function that wraps this, and indeed, we just provided 10 and the script displayed as a message. One thing I want to talk about that is very, very important is using debugging. So in Bash, you cannot really put a breakpoint, but you can output all the values, all the variables with evaluated values and all the lines that are being evaluated to the console. So when you provide this -x, you could also do this using set, but we could use bash -x to achieve the same. It will essentially give us very rich output, showing us how the script evaluated, and we can very easily catch any errors this way. So let's give it a try. This time we are providing Charlie, and we are using our... So now you can see the script prints every line. So line 4 has our settings. On line 18, we actually have a name variable, which during runtime evaluates to the word Charlie, which is the name we provided. Now we have our first conditional that says that our first parameter in this case is not equal 0. It just prints out the check itself. Now we have a function that uses, and so on and so forth. So it's kind of go line by line and evaluates in various ways our script. So let's actually provide an incorrect value here. So we're going to provide something like 10, and you see loop says, oh no, please enter number between. We can actually enter a word here or anything else, and only when we provide the correct number, script will finish. So that's it. I realized it was a really long video, but you can watch it in sections. You can just take one part of it at a time and just exercise. What is really most important is to write bash script, to try to solve problems and learn. Again, now with generative AI and all the documentation available, it's easier than ever, although obviously, as always with AI, it's dangerous to let it create everything without understanding it. So I definitely encourage you to read the documentation, understand what you're doing, and then if you want to automate some parts of your script, you can definitely work with AI to do this. So bash scripting is a powerful skill that can significantly enhance your productivity, and that's what also happened to me. When I started writing my bash scripts years ago, I have a big collection now that automate almost every part of my setup, whether it's personal use or work. It's been amazing. A few resources I want to tell you about, and I will link them in the video description. The man pages on the right hand side, which for whatever reason didn't loop through the topics as I was expecting to, but we only had these functions, but that's fine. So man pages is one. Man pages is a built-in help. We also have a TLDR. I can actually show them to you. So man bash, and we can see this is our bash script, and we can just read here everything and search. Let's say with maybe like this, we can see how those options are. Another one is a program called TLDR. Too long didn't read. So we can say TLDR, and we can then pick a keyword from bash. So in this case, we are using the word case, and it's takes a reference to bash manual, and then shows us how we can actually use it in our script, which is very handy if you forget the syntax there. There are a few online resources, which I will link later, but there's quite a few that are very useful. But those two that we cited terminal are quite nice to have. One script maybe that's very useful is shell check. So shell check is actually a program that it's like a linter for bash scripts. So if we run shell check on our examples, you can see that it tells us here that we used read without R, and if we would have a backslash in our response, it could mangle the response, which is a great advice. Here is also a style violation. It says that exit code directly if a command. So we don't need to actually to check an exit code. You can execute a command rather than check an exit code. But shell check is amazing for checking all kinds of errors and problems with your script. All right, this video has been really long. Thank you so much for staying till the end. If you have, otherwise, you can just slice and dice it and watch however you want. Thank you for your time. Thank you for watching. If you like this type of content, leave me a comment below. What are you interested in learning? Whether this was helpful, and maybe you would like to see some other things. And yeah, see you in the next video.